Aloha everybody, this is Gigi from Kauai Community College. This video is of the derivative of the inverse tangent. Inverse tangent now. And we're going to take the derivative of it. So suppose you have y is equal to inverse tangent of x. And the question is, what is dy dx? Same thing as you have seen in the inverse sign. If y is equal to inverse tangent of x, then tangent of y is going to equal to x. We're going to go ahead and take the derivative of both sides with respect to x, where implicit differentiation will apply on the left-hand side. The derivative of tangent of y is secant square of y dy dx. The derivative of x with respect to x is 1. So solving for dy dx, it is 1 divided by secant square of y. Now, question is, how do we express secant square of y in terms of x? Because we want the answer here to be in terms of x, right? So we know that cosine square plus sine square equals 1. If we divide both sides of this identity by cosine square, we will have 1 plus tangent square y is equal to secant square y. And tangent is x. Tangent of y is x. So then secant square of y in this case is 1 plus x squared. So we would say the derivative of inverse tangent of x is 1 over 1 plus x squared. And that is it. So next, we're going to go ahead and use it in an example, right? Let's see if we can do that. Derivative of inverse tangent of x is 1 over 1 plus x squared. So if f of x is equal to x multiplied by inverse tangent of x over 2, we know that the derivative of inverse tangent of x from our lesson there is going to be 1 over 1 plus x squared. We know that, okay? We are here in a product rule situation. So f prime of x will equal to derivative of the first, which is 1, multiplied by inverse tangent of x over 2, plus the derivative of the second times the first. So you will have the derivative of inverse tangent of x over 2 is 1 over 1 plus x over 2 square multiplied by 1/2, which is the inside derivative here, multiplied by the first function, which is x. Okay, so the derivative of the function is inverse tangent of x over 2. Not too bad, right? Let's go and take a look there. Scratch paper. 1 plus x squared over 4. That's x over 2 squared. Common denominator is 4. So I will have 4 plus x squared. And so 1 over it, the reciprocal of it, is going to be 4 over 4 plus x squared. And then you're going to multiply that by 1 over 2 and then times it by x. So you have an x over 2 right here. 2 cancel with 2 and then there's 2 there. So this part right here is cleaned up to be 2x over 4 plus x squared. Okay, that's some fancy algebra for you, but that's one way that we apply the derivative of inverse tangent. And the question really isn't asking for just the derivative function. It is asking for the derivative of a particular point. So then the derivative evaluated at 2 square root of 3 is going to be inverse tangent of 2 square root of 3 over 2, which would be just square root of 3, plus 2 times 2 square root of 3 over 4 plus 2 square root of 3 squared. And we're going to do some fancy math here. Okay. So when evaluating tangent of square root of 3, we would think which angle will have tangent equal to square root of 3. Meaning which angle where sine of that angle is square root of 3, and then cosine of that angle is square root of 3 over 2, and then cosine is 1/2. Which one is that? That would be pi over 3. Okay, so we're talking about that angle there. And then here we will have 4 square root of 3. This is 4 square root of 3 over 2 squares 4. Square root of 3 squares 3. 4 times 3 is 12 plus 4 is 16. You reduce that to get square root of 3 over 4. Okay, and that is the derivative evaluated at that point. 2 square root of 3. And that is it.